A very good morning to all of you children. How are you doing? Well, it's the first day of the weekend again. Back to work. There are two small topics left in this unit. That is, what is an element and how do we find out metals and non-metals in a table that you will study in detail later, but that's called the periodic table. So, just to give you a brief example, an element, this is as per the definition, is a substance that is chemically the simplest. Okay, when I say simplest, you can understand it's the superlative form. Simple, simpler, it is the simplest. And because it's the simplest, so you cannot break it down using any kind of chemical reaction. So, when I say oxygen or hydrogen or nitrogen or sodium or gold or silver or iron, any of these, you cannot break them down further using any kind of chemical reactions. So these are all elements. Now if you go into the detail, it's a pure substance. It's very important in chemistry, the purity of a substance that defines its sensitivity each time. You know, any substance, we always say it should be pure. Is it pure or it's impure? And it is made up of a single type of atom. Now, what do you mean by an atom? Atom is the smallest particle of any given element. Remember, I'm saying element. Okay. Now, they are the building blocks of the rest of matter. Like if I say proteins, immediately you know that proteins are made up of amino acids. So, amino acids are called the building blocks of proteins. When we look into the body, as we've studied in biology in the first semester, the human body is ultimately made up of very, very tiny cells. And what do we call them? We call them the building blocks of the human body. So elements, when we combine elements, like if I combine carbon, which is an element, and oxygen, which is another element, in a particular ratio of, let's say, 1:2, I have the formation of carbon dioxide. Why dioxide? Because I have 2 oxygen. And so you have 1:2 of carbon and oxygen forms a compound. 2 elements combining in a particular ratio form a compound that's called carbon dioxide. I take the same example of the elements of carbon and oxygen, but combining in the ratio of 1:1, they form carbon monoxide because it has just 1 oxygen. We are not going into the details of compounds because that you would be studying in grade 8. But as of now, you're just supposed to know about basically what elements are. So I'll give you some examples. You can take any other examples that you find. But iron, oxygen, hydrogen, gold, all these are examples of elements. Now, what's important is that an important number in an element is its atomic number. Now, atoms, I told you, are the smallest particles of an element. So, obviously, all elements will not have the same number of atoms joining to form them. So, we'll see that as we move on to the next slide. This is about how we talk about what elements are. Now, moving on to the third slide. Here, you have to identify the metals and the non-metals. It's a kind of continuation of what we've done before. You are already very clear about the differences between the metals and the non-metals. But here we are just going to talk about how to identify these metals or non-metals in a table that we call as the periodic table. I'll show you this. This is the part of the periodic table which I showed you in the previous slide. And what is the periodic table? As you know, it's a table you can make out. So it's a tabular display. Instead of writing it, we have put it in the form of a table of what? Chemical elements. Now, how are these chemical elements arranged? In increasing atomic number. I have written here only arranged by atomic number, but from left to right, it is arranged in increasing atomic number. Now, if you look into the periodic table slide again, it has horizontal rows that are known as the periods that move from left to right, and the vertical columns which we call as groups. Now, this periodic table lesson is an extremely favorite and an interesting topic. You can delve deep into it. I can go on and on, but let me just come back to how do we identify. Now, this periodic table that I am showing you here is not the complete periodic table. In grade 7, you need to just know about the elements from maybe 1 to 20. Okay, now let's look here. Start from your left hand side. The first element on top is written hydrogen, if you can see. Look on top, it's written 1. Now for this you can also please open page number 81 in the course book 9. That's the red course book. Okay, so we start off with hydrogen. Now hydrogen is a non-metal. Then we move to the extreme right. Can you see? It is written He or helium. Helium, neon, argon, all these are in group 8. I will explain to you. Please don't get confused. Slowly we'll go. So just look at the count of the numbers that I'm saying. Then come to the next period. Why period? Because it's going in the horizontal way. Okay. Now, so number 3 is lithium. Then there is beryllium. Then we move boron, carbon, nitrogen, oxygen, fluorine and neon. Please look into the table carefully because you're still not used to the short forms of each of these elements. Come to the next period. There we have Na, that is sodium or natrium. Then we have magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. And finally, as we come down, we have K for potassium or kalium and Ca, that is calcium. So we end at number 20. Okay, it's a simplified version again. This is I went horizontally. Now I'll tell you vertically if I come down. Let's say hydrogen, lithium, sodium and potassium. They all belong to group 1. Just adjacent to that, beryllium, magnesium and calcium. Okay, I'm sorry. Hydrogen is actually separate. It's an anomaly. You can't put it in group 1. I'm sorry for the previous statement. So, beryllium, magnesium and calcium belong to group 2. To the next group, that's boron and aluminium, that is in group 3. Carbon and silicon is group 4. Nitrogen and phosphorus are group 5. Oxygen and sulfur, group 6. Group 7 includes all the halogens. There are few more below, fluorine, chlorine, iodine, but here we are just taking fluorine and chlorine. And the last group, it's group 8, that's helium, neon and argon. These are the elements that are non-reactive. Okay, you may have heard about neon gases and the bulbs that we use, and helium, which we studied in non-metals, you remember, where the balloons are made up of helium. Okay, so that is the uses of these non-metals. Now, for the metals, to identify the metals in the periodic table, on the left hand side, that's lithium, sodium, potassium, beryllium, magnesium, calcium and aluminium. These are metals. So to the left of the periodic table, we have metals. On the right, we have non-metals. Okay, now each of the elements, they have different atomic number with different number of electrons. This from 1 to 20 that I read out to you. So if I say sodium, sodium has an atomic number of 11. Magnesium, it has 12. If you come to nitrogen, nitrogen has 7. Okay, now, so metals have properties that are in common and some properties that are slightly different. For example, if you talk about iron, right? Iron is hard and strong, but sodium on the other hand is very soft and it can be easily kept with a knife. Cut with a knife, but it is very it can explode, so it's always kept under kerosene. Okay, and it causes damage to our skin. But there are various other properties, as I told you, that it is an extremely interesting topic. We'll get into it later on in the later years of your chemistry study. But as of now, it's simple that you have to identify the metals and the non-metals in your periodic table. And here we just identify in the broader aspect that on the left hand side we have the metals, and on the right hand side and in the central part we have the non-metals. Okay, thank you.